Hey there. Welcome to our YouTube tutorial. You don't need a technical background to join us. We're making this as engaging and understandable as possible. Stay with us. And after this video, you will clear up a bunch of misconceptions about three buzzwords: artificial intelligence, machine learning, and deep learning, which have gained immense popularity in recent years. Starting with broadest possible question, what is artificial intelligence? I was not even aware about it. AI is complete field of study just like physics, and machine is subset of AI much like mechanics in physics. Going further down, deep learning is subfield of machine learning. Deep learning modes are further broken down into generative models and large language models. At the intersection between generative and LLMs is the technology that powers the applications like ChatGPT and Google Bard. Let me know in the comments if this was news to you. So, now that we've dipped our toes into the AI pool, let's dive a little deeper. We'll explore each concept further. By the end of this video, you'll be amazed at how much you've learned. Starting with machine learning, in a nutshell, machine learning is a program that uses input data to train a model. That trained model can then make predictions based on data it has never seen before. Let's understand, with the real use case, let's say you trained your model based on McDonald's sales data. You can then use that model to predict how well a new product from Burger King would sell based on Burger King sales data. Two of the most common types of machine learning models are supervised and unsupervised learning models. The key difference between the two is supervised models use labeled data and unsupervised models use unlabeled data. In this supervised example, we have historical data points that plot the price of property against the prices, and using a supervised learning model, we can now predict what should be the price of property based on area of property. One thing to keep in mind here is there are other factors also on which prediction dependence, like in this case, prices vary based on locality of your property, builder, and amenities. Whereas unsupervised learning models, we look at the raw data and see if it naturally falls into groups. Like here, when we passed data, it grouped into 4 different clusters. Unsupervised learning is helpful in defining customer personas, makes it easier to understand common traits and business clients' purchasing habits. Unsupervised learning allows businesses to build better buyer persona profiles, enabling organizations to align their product messaging more appropriately. Now we have a deep learning with a basic grasp of machine learning. It's a good time to talk about deep learning, which is just a type of machine learning that uses something called artificial neural networks. Don't worry, all you have to know for now is that artificial neural networks are inspired by the human brain and look something like this: layers of nodes and neurons. More the layers, more powerful the model will be. Deep learning model is trained on a small amount of labeled data and a large amount of unlabeled data. This method of learning is called semi-supervised learning. The labeled data helps the neural network to learn the basic concept of task, while unlabeled data help the neural network to generalize to new examples. For example, a bank might use deep learning models to detect fraud. Bank spends a bit of time to tag or label % of transactions as either fraudulent or not fraudulent, and they leave the remaining % of transactions unlabeled, because they don't have the time or resources to label every transaction. The magic happens when the deep learning model uses the % of labeled data to learn the basic concepts of the task. Now model will first identify good and bad transactions, then apply those learnings to the remaining % of unlabeled data, and using this new aggregate data set, the model makes predictions for future transactions. That's pretty cool, right? Finally, get to generative AI. Generative AI is a subset of deep learning. Generative models learn about the patterns in the training data, then, once receive some input like a text prompt from us, they generate something new based on the patterns they just learned. Let's consider this example. We show pictures of cat to model. Generative AI model will look for patterns and data points. In this case, all pictures have 2 ears, 4 legs, and a tail. When asked to generate something called a cat, the generative model generates a completely new image based on the patterns it just learned from the input data. Super simple way to determine if something is generative AI or not. If the output is a number, a classification spam, not spam, or a probability, then it is not generative AI. When the output is natural language text, or a speech and image or audio basically, then it is generative AI. Basically, generative AI generates new samples that are similar to the data it was trained on. Moving on to different generative AI model types most of us are familiar with. Large language models are also a subset of deep learning, although there is some overlap between LLMs and generative AI, but they are not the same. An important distinction is that large language models are generally pre-trained with a very large set of data and then fine-tuned for specific purposes. Let me explain what I mean. Okay, think of large language models like a student. At first, they go through school and learn all the basics: reading, writing, math, you name it.
But then, let's say this student wants to pursue a specific career path. Maybe they want to become a doctor, a lawyer, or an engineer. They need more than just a general education. They need specialized training to excel in their chosen field. Here, they dive deep into their chosen field, learning all the ins and outs, mastering complex concepts, and gaining hands-on experience. They become experts in their specialized area of study.
Similarly, large language models start with a broad understanding of language from their initial training. But when they're fine-tuned for specific tasks, like writing medical reports, analyzing legal documents, or coding software, they undergo specialized training to become highly proficient in those particular areas. Large language models. They're first pre-trained to solve common language problems like text classification, question answering document, summarization, and text generation. Then, using industry-specific datasets, these LLMs are fine-tuned to solve specific problems in retail, finance, healthcare, entertainment, and other fields in the real world.